Okay, for this last panel, one of the reasons why I put this sustainment panel in there is because it seems like every development program we get in, the first thing that goes away or gets sacrificed is the sustainment tail. Given the fact that this is a life cycle process, I wanted to make sure we stretch the life cycle here and talk to some of the folks that are working on that end. Brandon's from Bell. He's working their life cycle management program. Jason Rios is from Sentient Science, I'm sorry. Jonas is from Wichita State, and Patrick Wong is from Microsoft. So we're going to hear from these folks and see how that digital thread reaches all the way to the sustainment tail of the product. Anybody want to go first? Go, Paul. Go first.
Okay, and did I hear Paul first?
Yeah, Paul
Yes,
first.
yes. Well, it's loading the charts. Paul Jonas, Wichita State, technical director at PowerPoint. It's an institute that's actually partnered with the Army for research. Anybody wants to know about Wichita State and what we do, see me later on this. Let me get to that. So what we're going to do is transition a little bit. We've been talking a lot here about designing, specifying, modeling new stuff. What we're going to talk about is how am I going to enable new technologies, some of the digital engineering to go help us take care of some of the old stuff. Because last time I checked, we're going to have to keep it around for about another 40 years or something like that. And we have to do it a lot more cost effective than we have in the past. So again, what does it mean? Just model-based, authoritative truth, and you have use with a life cycle. And of course, that's probably where we're going to sit talking about this afternoon. Actually, you need to tell Chris.
Yeah,
Chris. Oh, Chris, next chart, please. So we have a lot of experience in modeling, a lot of projects, and again, let's just go to the next chart. I'm talking very specifically about what's going on. So a lot of the things we have the problem when we're talking about our old assets is those things were designed 40 years ago, probably on paper, papyrus, maybe, or whatever it was. There is no digital definition for these. So we have embarked on a thing of creating digital models for older assets. And of course, the way it works, we get an asset, we work with the OEM, they give us the entire drawing specification. Those are the current programs you can see that we're working on right now. Next chart, please. And so the way it really works is it's this idea that we tear it apart and we scan it. But scan is not the type design. Let's just be real clear about that. What we do is we model it from the original type design using CATIA. Yes, and we have about 250 students that do that for us. I'm going to step a little back to the other thing and kind of give a shout out to the SO. With 250 students coming in, we want to get them as freshmen. We don't want to wait until they're juniors and seniors until they have their design classes. So DeSoto's worked with the high schools around Wichita, and they have full seat licenses. So the kids that actually come to Wichita State have had like 2 years of CATIA training before they even show up at Wichita State. They're wired a little differently than me, so it works. So we grow our own to go feed the pipe. So then what we do is we make the model, and then again, we scan the part because sometimes those old drawing sets, you know, sheet number 23 is missing or there was a discrepancy or something, but we use it in the process to validate, okay? So the idea is you have to have truth. We work with the OEM, any discrepancies, and then we come back into, that becomes the digital type design, okay? And it has to be an equivalent, it has to be validated. It's just not a bunch of scan bits and pieces that you have no idea what the reference is. And of course, those are fully annotated with all the drawing notes and information associated with it in the modern form. From that, then you can go ahead and make, let's say, a finite element model, any type of, you know, model-based engineering approach off of that because you're using a validated source of truth. Next chart. So I talked about all the programs that we're working. I think the Apache's next in that for us. F-16, we're doing 2 blocks, 30 and 40. So we'll have those 2 variants. Next chart, please. Let's go to the next chart. So again, once you have that, then you can go and you can have CFD against that original data. Or again, you can find an element model validation. Again, I look at a finite element model as just a bunch of nodes, and I've created a ton of NAS trash in my career as well. But the point is that unless it's validated against something for its configuration, it's really not worth much. So again, we did some reapers. Next chart, please. Oh, I won't take any more than 5 minutes of this. Again, this is the MQ-29 reaper that's in our rig that we did static and fatigue test with. But again, from that, several thousand strain gauges to help us validate. Next chart, please. Same thing we did on the Blackhawk helicopter. We had a flight asset that we strain gauged, that then we have a way to go validate the final model for that as well. So we have loads that actually now are tied back to the source of truth. Next chart. Next chart. Next chart, please. Sorry about this. Automation doesn't work when you go to PDF. So once you get that, okay, so the next thing that you go around the circle, then you have the innovation. Now I can start looking at modern tools for building, and of course, this, like I said, modern manufacturing. But I can also get into things like digital X-ray, automatic paint removal, robotic repair, and so on and so forth. But again, so you think of the digital models, that type of baseline, that becomes the enabler that allows me to go implement some of these new processes, modern digital processes. It's going to really make a difference for us in the our sustainment life and outcome. Next chart, I'm going to get a couple others. Oh, so keep on going through these until you get the videos to click. Some eye candy with this. Another project that we had is what we call Jarvis, and this is nothing more than a scanner and a drill head. So you got to know, one of the things about sustainment is after replace a part, you take the part out. Of course, it was hand drilled, and none of those holes match exactly where the type design was. So what I do is I take the old part out, strip it down, we put it in a machine, it scans it, it gives us position vector, put the blank part in, and I'll go back and make an exact replica of the part. So this is the project we did, again, in taking established technologies, put into an application that would drastically affect sustainment. So part we had on an F-18, it kind of sits between the engines, 3,500 man hours to replace one of those. And I think we're taking about half of the time out of that. I'm doing this by just giving a part that has matched holes. Next chart. And then again, I can do something. This is Jarvis 2. It's an automatic blade repair cell. But again, what it's doing is just taking existing technologies from scanning, shearography type, laser shearography, thermal inspection of the blade itself. We can do automatic paint removal. You can do automatic painting. You can do automatic grinding and removal of damage and repair. You can't. The engineers, the technician still has to take the patch and take it back to the machine to put it on. Otherwise, it's pretty much an automatic process. But again, I said it's just a bunch of enablers once you get that digital data. Next chart. And then, of course, the other one that's really important to this is not only with, now that you have the technologies, you have to go develop the infrastructure. You have to make that starts working within the systems. You get your work instructions, you get your CAMs, your LMS. Everybody understands that this is really the tough one to go do, and especially on an old depot, an old system. Digress a second here because I've been working a lot with the depots. I think I visited every depot in Arsenal this last summer on helping with the modernization plans. And a lot of folks take modernization like a guy with an old truck. Okay, and this truck has an 8-track player in it. Okay, and they want to modernize, so they go looking for a digital 8-track player. I tell them that's not modernization. But on the same light, though, if I have a process where I'm inspecting the gear with the calipers and a feeler gauge, and I take it over and I buy a real fancy, like a Keon's blue-white laser scanner, and I just use that same data as a go, no-go, I'm using my digital 8-track player. Okay, but if I take that data and I pass it on to something like, what Jason's going to talk about, his system, where I can actually analyze the wear pattern of that gear, and I can be predictive, and I can maybe tell you when I have to inspect or tell you when I have to replace, then I can really affect the outcome. So we have to be careful how we implement technology. So I'll get off my soapbox, go to the next chart. And again, work force of the future. And again, I think I talked about how we do it a little bit differently. You have to think out of the box, growing your own students. There was a comment made a little bit before about taking graybeards and infiltrating them with students. I'm going to flip that and I say, I'm going to take my students and infiltrate them with the graybeards. Now I got a student that knows, they're pretty good at electronics. I still was a paper guy with like you and Bill, and pen and minor and, eraser shield. But they can do so much more. And of course, you pair them now with the Gradebirds, they become a team, they become energetic, they become energized off of it again. We call it USERM. Again, off of, there's a story, we had a company up here, and of course, they had an engineer working with us. And then they were doing a design review, and of course, the chief engineer came in from overseas and was talking and said, what'd you guys do to Adam? Well, what do you mean, Adam? Adam was our best engineer. I mean, he came in every day, he wore a suit and tie, showed up, and he was the best guy we had. Now he shows up in a t-shirt, his hair's all funky, and he wears these jeans and slippers. But he's never been better. So again, you look at this thing, it's just a different dynamic that you have to do. And I don't want to say that we have the magic sauce, but the point is you have to think outside the box if we're going to go work this a little bit better and go to our workforces. Okay, I think I'm done. Next chart. You can get with me afterwards if you want.
Great. Mine actually blends in.
Makes sense.
Right here. Hey, so Patrick Long, so always bringing that up. I'm the Microsoft guy. Ground rules, I can't fix your teams. Mine doesn't work. I can't talk to people on DoD. What's going on? I talked to Sadia. He says he doesn't know, so he just wanted me to let y'all know that nobody knows how to fix teams. So I'm sorry, but we're working it. But Army 365 is coming soon. It will save the day. I promise. Just trust yourself. Trust me in that. So I'm really honored that I got to be here today. Dr. Lewis, we kind of bumped into each other on accident almost a few weeks ago on the telephone, and realized rather quickly that this was a really good opportunity to talk to y'all a little bit about how Microsoft has really started to pivot away from just a bunch of people in blue jeans and sandals, and like I'm overdressed for a Microsoft meeting at this point, just so you know. We've progressed from that and stopped hiring necessarily on the federal side folks who are brand new and really good with computers, even though that's great. We need those people. But they started to hire old people like me, people who were served in the military. What I've realized listening to y'all talk is, when I first started flying as an instructor pilot, I was thinking, that's center of gravity. I'm tip of the spear. I'm teaching people how to fly. And then I got stuck as a maintenance test pilot later in my career, and I went, no, this sucks. And then I realized quickly, no, this is actually center of gravity for Army aviation, maintenance and supply chain. Because at the end of the day, it does not matter how good those pilots fly or how outstanding that airplane is. If it can't take off, right, we got issues. And so it's probably was the most beneficial part of my career. And that has led me to be able to tell Microsoft about all the stuff that was broken in Army aviation. And they now say, well, what would our stuff fix? So your discussions on system engineers and trying to solve the chicken or the egg discussion on what's the best type of system engineer, it's very similar to what we're doing, right? Do I want to just have a bunch of smart people create really cool software or platforms, but they don't really understand how to solve those problems? And that's where Microsoft really was, I would say, 5 years ago. And today, you will find a lot of folks like me, some way smarter, much smarter, most definitely. Who can say, well, that type of technology can do this. I'll give you an example. We'll talk about it real quick. The HoloLens 2, if you're familiar, you may be more familiar with what's known as IVAS. IVAS is 22 billion with the Army commitment to Microsoft to essentially create night vision goggle lens for door kickers, right? Essentially, that's what it is. It's a tactical device. It can do all sorts of cool thermal imaging, replacing MVGs to some point, right? But there's only what percentage of the Army are door kickers? It's probably pretty small compared to how many are combat service and support personnel that could use. They don't need a cool IVAS that's for door kicking and seeing in the dark. They need to be able to bring in things like augmented reality and mixed reality capabilities so that we can help them do their job better, faster, cheaper, more efficient, right? Unfortunately, that's a crawl, walk, run with the Army. When I first got here a year and a half ago, we were about to get rid of HL2. However, 2 or 3 of people like me said, wow, the Army would probably really like that. Well, how about I go see if they're interested? And that has sort of become a resurgence. So what I'm going to talk to y'all today quickly are 2 major issues. We're talking sustainment. What I want to focus on is the technology that Microsoft's bringing to bear to help sustainment, right? Without eliminating jobs, right? Or without necessary, but instead giving maintainers and artisans and those types of folks the ability to be able to do their jobs with tools that don't require them to become data entry personnel. I remember the day we got items and I hated it. I was like, can I please have my green logbook and my pencil back? Because this is miserable. I'm at 2 a.m. I'm trying to type. The keyboard's too small. My fingers are too fat. And it was a terrible thing. And I ended up spending, our technical folks, QC people, for instance, ended up spending hours of their day doing nothing but data entry. Did we help them? Is the data actually getting anywhere that could help us? Eventually, it gets to places like the AEDs of the world, right? Where we have a catastrophic event and we need that data to figure out what the heck happened. But then we all start going, but wouldn't it have been nice to have had that data with zero latency, with zero errors, and in some type of data schema that made sense so that we could have potentially predicted those failures, right? So those, the two initiatives I'm going to discuss today, and next slide, please, Chris, are, and go on and skip this one too. Empowering the global multi-domain operation, right? And this is an overused term. I get it. You hear it in all the grades, all G3 slides, right? MDO. But at the end of the day, that's kind of what we've all been talking about here. You're talking about, I got people across the enterprise from R&D to acquisition to DMIL who need data and they can't get it. Well, that's because the way we set it up wasn't that smart, right? And so we get into things like the cloud, the big cloud that nobody seems to be able to define. Here's what I can tell you today. Microsoft has put a huge commitment into the cloud to have the largest private network across the globe. If we were at a phone company, we'd be the second largest phone company on the planet. But we don't use those for phones, right? We're using them to move data sets. The Azure Gov cloud is all the way up through aisle 6 and becoming aisle 7 rather quickly. And we can extend those security processes all the way out to the edge. What do I mean the edge? That's what I'm about to talk about. All the way to the tactical door kicker or the pilot or the maintainer or the aircraft or the weapon system itself that's creating terabytes of data that we've been collecting in the basement of the Department Center for decades, right? We all know this. That data gets shipped all over the place. It goes to Carnegie Mellon. Please, smart people, figure out how to do something with this data. We send it to Corpus, or not to Corpus, down to Biloxi and the Corps of Engineers and say, y'all got lots of big computers. Can y'all push this data together and tell me what the heck's going on? At the end of the day, here's what I would say. When I talk to folks like Mr. Mason and and those folks at PO Aviation, I used to be with a different company and we did data analytics. And I left that company and came to Microsoft because of one thing Mr. Mason said to me, which was this: Pat, if I ain't got any pipes, I don't give two craps what your AI does, because I can't get you any data to do anything with it. And it's garbage in, garbage out. So until you can help me collect, normalize, and transmit data from the edge, from my airplanes, into a single, y'all use those terms earlier, the authoritative source of data somewhere in the Ethernet, it doesn't matter what we do from an AI ML perspective. I can only predict maintenance based on the things I can say the data would support. And there are outstanding predictive maintenance solutions across industry. I mean, you can name them off. We could, C3 AIs, the Palantirs, Microsoft has their own thing, to be honest. So, but all of that is deemed somewhat worthless if it's garbage in, garbage out. We did a study working with the CAB-AL last year, just working together with Al and his folks over there. And the intent was just to say, could y'all just deliver me some data coming off an airplane in a single format that I can use to do any kind of analytics on? Meaning, is it in one format? Does it make sense? Do I not have time overlaps? And the answer most of the time was no, which we're struggling with that. So what Microsoft has done is we've created the first solution I'm going to talk about. Next slide, please. Well, we call it physical to digital. And what that means is we have a device known as a Sphere IoT device. We used Sphere with Starbucks for the past 5 years to tell them if their coffee machines were going to break or not, to make sure your lattes were there when you put it on your little app and showed up. They knew that it would be there. And we showed up, people like me, and said, y'all can do that? And they're like, oh, yeah. Well, we have a couple partners that provide radios that are already on board military vehicles. They're used for Blue Force Tracker, those types of things. They create a kinetic mesh network, right? We can place a Sphere device, we already have, to be honest, on board with our partner's radio. And that system can then sniff the bus, so to speak, and provide that data in real time, if chosen by the Army, into an Azure Gov environment, completely secure, from the airplane to a cloud environment, right? Now, do I want to do that when I'm cross-plot, or whatever the term is these days, because I'm not the right acronym anymore? No. But obviously, I'm sure Rockwell and Raytheons of the world could probably provide you a switch or something on an MFD, allow you to turn that thing on or off, or we can give you a button in the back to turn the power on or off, right? So here's the thought. If we can do that, and we can move that, and it's a single system, right? So it doesn't care if it goes on a Black Hawk, Chinook, the greatest aircraft on the planet, by the way, or the new Flora, Floras, etc. It's the same thing. You gotta go through AD, right? And that's kind of been a stopping point at this point, is finding dollars to go out to RTC and actually test the sucker and see if it works and see if it's worth doing airworthiness testing on expensive stuff. But Microsoft is committed to do this. And so unfortunately, the CAB-L is more hardware focused at their integration lab. They're not so focused, but it sort of proved the point. Like Al was even kind of surprised that I can't give you we're not set up to give you the actual files that Apache creates, or that a Chinook, or I hear things like, well, the Chinook's just so stinking old, man, that data crap anyway. That's what I would get told as well. But think about this. If we can do this, but here's the key, and this is for all you folks, you system engineer folks, data folks. But even if I did this today, I'm wasting bandwidth, I'm wasting time, and I'm wasting the government's money on Azure consumption, as much as I love it, for my bottom line, just to be honest. At the end of the day, you're wasting the government's money if the industry or the Army does not create data schemas for each of these weapon systems. Just tell me, like, do y'all really want to know if the landing light is on or off? I mean, it's recording it every quarter of a second, and it's every time it turns on or off, it's in that data. Do you really care? Because guess what? When you run some basic statistical correlations, there's a pretty good chance you're going to find an R-square somewhere that says the landing light's related to transmission failure. Just because they fly at night a lot, sometimes they got the landing light on and the transmission fails a lot. Is that really predicting anything? Not really. So Microsoft is looking for some help to help make that decision and take that next step. Understanding we have issues around proprietary data sets, et cetera, and sometimes the OEMs may or may not want to cooperate fully with providing, the reader or the whatever it is, the translator, so to speak, to make the data sets into just give me a CSV, man. That's all I need, just a CSV that makes sense with some column headers that are in English. And they don't say Alpha Bravo, little exclamation A21, which is the engine oil pressure on the #1 engine. Does anybody know that's the engine oil pressure? Well, no, that other guy has that dictionary for data. So there's some work on both sides to be done. But the good news is this exists today. And it's really pretty simple process to do. The Sphere device comes with complete secure encryption of all the data sets, because that's the first question I get. Oh yeah, you can't be sending that stuff wireless. That radio is already good. And the Sphere puts all 7 levels of cloud security on top of that in as well. So as far as security goes, that's actually about as good as it's going to get, moving data off of platform, right? But what we need is Army Aviation, that's who we're talking to today, to decide to partner with us to do the hard work, because the hard work's really not on our side anymore. The hard work is on y'all side. Am I willing to put the assets and the resources to bear to actually open those things up, or work with Boeing, whoever, Sikorsky, to actually be able to access that data in real time coming off the platform? That's the first thing. Second, next slide. Because if we do that, now I'm not just limited to airplanes, right? And we can do things that I know Mr. Holcraft and those people want to do, things like, we really need to write this into the requirements. So I heard that earlier today. I totally agree. Until you get it into the acquisition process up front, you're in deep trouble. But you have 2 amazing opportunities in Army Aviation to do this, and that's FLRAA and FARA. And I know I believe there's a general officer board today that's writing those requirements. And so I think this is a good opportunity. But once you can do that, now you're not limited, right? Now it's the next generation combat vehicle, optimized combat vehicle. It's any weapon system in the Army inventory and DoD inventory could be accessed with a very similar. Now, you don't want to put that big old radio and IoT thing on a gun. I got it. But for sophisticated weapon systems that are generating terabytes of data during hours of operation, That's probably a pretty good thing, because here's one simple use case. Today, with that system in place, I could actually tell you pretty quickly how many actual flight hours that aircraft flew versus, and I don't know if this has changed, I don't think it's changed, but when I was flying, I was the one recording the flight data. I didn't do decimals a lot, just gonna be honest. It's late, I started the clock late, I started it early, I didn't remember to stop it when I shut down. I flew, I think 3.2, but I logged 5.0. Didn't seem like a big deal to me, but when I was an instructor pilot at Korea, I had a kid who needed 8 hours of goggles to be proficient in Korea, but after 4, he's good, or we're good. And maybe we might not necessarily fly them the full 8 hours because they're already proficient. Here's what I can say. That airplane, every one of these airplanes that we're flying today knows when I took off the ground, because they all got some kind of squat switch, and they all know when dual engine shutdown occurred, either catastrophically or on purpose. And those data sets are sitting there. Very quickly with systems like these, we could probably, well, let me say probably, I know with complete 100% accuracy that we could define what actual flight time was on every one of these. This is what's done in industry today, almost major system. I mean, Caterpillar, if you got a Caterpillar tractor, they're tracking exactly how many hours you're operating that sucker every single day. Why aren't we doing that today? Because here's the thing, take that to the next level of maintenance. I'm driving my entire maintenance, what pilots are saying. And I'm not gonna throw a number out, but I'm gonna say this. There's a pretty good chance we are artificially inflating maintenance and supply chain requirements because we're just not accurately recording flight time, even though systems exist today to do so. And this is so politically charged, I get it. But here's the thing. They got a system for pilots to log flight time in and their training records. It's completely separate now, called KFIRS. Send me and GCSS Army the maintenance stuff so I can actually drive my bank time by what the airplane did. Y'all can go say you flew 8,000 hours over 20 years. We don't care. But don't influence my supply chain and my maintenance operations because of you can't do decimals. I can't do decimals. So that's the first one. Next slide. And I'm going faster. Let's go to the next slide. Yeah, we can do it. I only want to explain to y'all. Disconnected operations becomes always the thing to everything. I've been talking disconnected operations since the day I got in aviation. Well, we can't do that. We have disconnected operations. Sorry, go away. You don't have disconnected operations anymore. All right, so here why? Microsoft has created what they call Azure Stacks. These Azure Stack devices are as small as something in a backpack to as large as that freaking Connex that I could send in a C-17 with any cab. And that is Azure Cloud, period. Army 365 is coming. We are moving to the cloud, whether we want to or not. Eventually, in 5 years, you'll all be operating in SaaS environments or IaaS environments using stuff in the cloud for the most part, okay? But here's the thing. When I go and my 3 people go to Djibouti by my lonesome and everything I operate is cloud-based system, what do I do when I'm disconnected and I can't access my flight records? I start to insert data latency issues into my data, right? All these things that we hate today that we want to do predictive maintenance, but we know we can't because we haven't fixed this. That's essentially cloud in a box. It provides you every single thing that your Azure Gov environment would provide you all the way through all 6 in a deployed environment. But yes, it does have to connect sometime. I get it. All right. So if I go somewhere and I don't have satellite or don't have Nipper or whatever authorized transmission capability I have, it doesn't help me. Other than this, it lets me continue to operate normally. Remember how we used to migrate logbooks until the dude walked into the hangar and actually migrated, which didn't always happen? The information was just sitting there worthless. And as we all know, some of that information could be very time sensitive, especially when you start talking predictive maintenance for potential failures, right? Got the Coke can in the transmission that we all saw, probably if you were an aviator, the slide where it cut through the transmission in like 10 hours. Well, I bet you there was a vibration in there somewhere that if we told somebody, we might have known that they'll look. These are things we're talking about. Azure Stack can do that. And we can deploy these with any unit across the globe. Next slide. That's the end of this one. So I didn't miss one. That's okay. So the second thing, HL2, because it's like the big pizzazz, and I'll go fast, Bill. Dr. Lewis, I promise. HL2 has become this huge, all into this huge training and maintenance enabler. And there was a slide that's not here. 2 main things it does. We're working at I visited Anniston, and I visited CCAT, and I've visited now Letterkenny. We're working with Letterkenny on an HL2 maintenance modernization project. 3 major goals, or 4. Number 1, we're going to use it for remote. We have a thing called remote assist, where whoever's wearing the HoloLens, no matter where they are on the globe, if they have connectivity, you can be sitting at your office in the team and see exactly what they're looking at using holographic capabilities that will appear in their view and allow them to conduct maintenance. Letterkenny is excited because they send teams to Germany all the time to do nothing but look at a part and determine its status and then come home and wait to order the parts. Well, what if Letterkenny now just says, well, turn it on, you're looking at it, hey dude, look on the other side for us real quick, open this up, got it, report done, I'm out, going on lunch here in Chambersburg. The end. Think of the savings. Second, guides. You've probably seen these videos. Every Mercedes-Benz dealership on the planet today is using a HoloLens 2 for using remote assist and guides. The guides feature provides an ability for users like the Army to be able to implement whatever they would like to enter for training or for guidance, right? So let's use our example, the Army Aviation. I can put the entire TM in and I can use voice recognition and say, hey, I'd like to conduct task 1022 on a Chinook today. Boom. And the holograph appears with their TM and they can stick it wherever they want to stick it. They can throw their teams over there, their email, whatever they want. And if they're not sure which way to turn the wrench, we can provide them with an hologram in their view that tells it, you want to turn it this way, dude, or you want to put it on this angle, perhaps, because y'all know that sometimes just putting the screw in the right way with the right angle matters. It just does. And then the third thing is object recognition. And this is getting into a lot of the cool things. And Paul, you really got me excited because this is the issue in Chambersburg. They don't have CADs. On the majority of the weapon systems that they fixed today, they could not generate one single CAD for us from the OEM to inject into HL2 so that we could provide them with Azure object recognition. And their reason, sounds like it's a big issue, is that the Army didn't require them to give it to them, the acquisition process. So we have people tearing down entire Blackhawks to create their own CAD models. I think AMCOM actually just started that initiative not long ago. We're going to be doing the same thing at Letterkenny, but here's what we can do. With an HL2, you can look at a part. If we've created the model, we've ingested into Azure Object Recognition, they can look at a part, have no clue what it is. It will identify it and pull up the technical manual or any engineering information associated with that part or supply chain information that they need. And this is the really cool part they're excited about. And if I need to order parts from LMP, I can do it right there inside of Teams. I don't even have to know how to get into that stupid SAP thing that all of us hate because it's confusing. I hate it. At least people like me that have victims of Alabama public school education. I hate it. It's hard. I don't know how to use it. It takes us forever to do it. So they're going to be able to now look at a part, identify it, determine if there is something wrong with the part that needs to be repaired, and then order that part in their HoloLens with their voice or touching, doing this crazy touchy. It looks crazy to y'all because you don't see what they're touching, and order that part into LMP. And this is going to be, we believe, a huge part of convergence with LMP and the MBSE and all that that's ongoing right now with LMP. And then the final thing it's going to really assist them with is the training issue. I didn't realize that there was such high turnover rates at the depot, assuming they all have this issue. Letterkenny is experiencing 20 to 40% turnover annually. Their training burden becomes ridiculous. Teaching somebody how to do X, Y, and Z on a Patriot missile system can be complicated. But if I have an ability to ingest the training materials and provide them with over-the-shoulder assistance via the lens, they believe they can cut training times in half. They did one little ROI, and I'll shut up. The ROI they completed was just, they would save $10 million a year in labor just by logging in and out of LMP with a HoloLens. Because in today's world, if you walk through Chambersburg, there might be 5 laptops on the floor. Well, they all line up and they wait. And then when they get there, it takes a little while to actually do the actual logging in. $10 million annually in just labor cost by logging in and out of a lens through a Teams environment directly into LMP. And oh, by the way, AMC gets extremely happy because now the data that's actually in LMP might be more beneficial. It might actually be tracking transactions properly throughout the supply chain. So that's what Microsoft's got going on. I'll stop. Thank y'all so much.
Thanks, Patrick. Jason, go to the next.
Sure. This is really cool.
Okay. So just, I guess, a little context for why sentient science is kind of up here today. For the past 15 years or so, we've been working with Army Aviation to develop physics-based modeling and simulation capabilities to be able to predict the life expectancy of drive systems. So some of the concepts we might talk about today might not be applicable to all the aircraft systems, specifically things like LRUs, but it kind of aligns with kind of our vision for how technology like ours fits into the sustainment enterprise, especially for things like future fleet. So, normally we talk in terms of diagnostics and prognostics, but today I'd kind of like to use terms like leading and lagging indicators when we talk about predicting future health state, because really sustainment kind of boils down to being able to accurately predict the future health state of your components. So if we could go to the next slide. So yeah, everybody's probably familiar with the idea that economists use leading and lagging indicators to be able to look at the current health state of an economy and also make future predictions. And that, I think, is very analogous to how we approach things in sustainment for things like, aviation assets. So what you want to do is you kind of want to use the available data to analyze your past performance, then also use additional tools to be able to look at kind of your future operations, things that have not yet happened. So it's the idea of kind of leveraging that knowledge from the past to inform and refine our predictions for the future. So just to pull one element out of here, just as an example, I'm going to pick on vibration detection, right? There are some excellent capabilities out there for both diagnostics and prognostics that rely on the outputs of vibration sensors. But it's still a lagging indicator, right? It's in order for a vibration to be generated, something has happened within the system, whether it's a crack or a pit or a STOL, whatever it is, something generally irreversible has happened to those components. So it's something that is kind of in the past. And then looking forward to future operations, you're looking at things like flights you haven't flown yet, forecast usage, operational environments, the maintenance strategy that you plan to use for the foreseeable future. Maintenance-free operating periods of 50, 100, 200 flight hours. What impacts will those have on the reliability of your systems in the future health state? So if we go to the next slide, please. So lagging indicators can actually be really useful when the historical data or the historical usage is consistent with what your expectations are for future usage. But what happens when that's not necessarily the case? Let's say, you look at the difference between operating in a desert environment versus an Arctic environment, right? One of those situations involves a lot of operations where the aircraft is limited by the TGT of the engines, right? So maybe you're not able to, in those operations, fully load the gearboxes and the transmissions during your operations because you're being limited. You move to an Arctic environment, that's not the case, right? The TGT limiting kind of comes out of the equation roughly, and you start looking at situations where maybe those gearboxes are the limiting factor in those flights. And to kind of throw an additional wrinkle on top of that, what happens when you do something like change out the engines, when something like ITEP comes into play? And now all of a sudden you've got an engine that exceeds the capacity of what you've had historically. So you've got all this historic data that was based on these older operations. Now, what's your planning factor going forward? How do you adjust for that? And then maybe even another step further, what happens when you have something like future vertical lift come along that's going to have revolutionary new designs that have relatively minuscule amount of flight hours, for the foreseeable future, right? What are you going to base those predictions on going forward? If we could go to the next slide, please. So for drive systems, it's invaluable to be able to have some capability to be able to kind of predict the accumulation of damage over time and kind of correlate that to usage. So I kind of stole this chart from our scientists. It's a little blurry, I apologize. I hope it's readable in the back. But I kind of refer to this as the hurricane chart when I talk to our guys, because to me it kind of closely resembles this hurricane tracking charts that we're all, if anybody from the South sees these fairly regularly during hurricane season. And that is, I think, a really good analogy for the predictions that we're trying to make in aircraft health. So you think about hurricanes, when they first started, the tropical depression out in the Atlantic, that cone, that kind of potential landfall cone is pretty wide, right? Because there's a lot of uncertainty, a lot of things can happen in the development of that storm and as it progresses towards land. But then as it starts to move and as it starts to be better developed, more data is collected, observations are made, and over time, that cone starts to get more and more refined and get narrower and narrower. And that's kind of what we're looking at here, but in terms of health, aircraft health. So if you look at it, in terms of being able to predict from, kind of time zero, at what point a system is going to reach that red line, that failure threshold. And in this case, think of failure threshold as not like the complete failure of a system on wing, because we don't do that in aviation, but it's whatever threshold you've established that aligns with your risk tolerance. So it could be vibration indication of a certain amplitude. It could be an observable amount of damage that exceeds the allowable damage for a component, whatever it is. But that's kind of the point at which you've decided that my risk tolerance will not allow me to leave that component alone. I'm either going to repair it or replace it, et cetera. So really the job is to try to predict at what point that green line, which represents, say, the notional component that we're looking at, is going to intersect that red line, because that's where we've decided that action needs to happen, right? And at any point along that lifetime, we can assess the current state of that component by all the data that we've collected up to that point, right? We can make projections about the health state of the asset at any particular given time, and also create a probability distribution function of the likelihood of it failing, based on what you know so far. But really, there's still a lot of time to travel between that current state and where you get to where the green line crosses the red line, right? And you can see where it crosses up there. That's its own probability distribution function, the remaining useful life. I know we throw that term around a lot, and it's not always appropriate, but it's on the chart, so I'm using it. But realistically, where that probability distribution function sits on top of that red line, that's where financial decisions are made, right? That's where investments are made in either maintenance resources, inventory, whatever. So your assessment of where that landing point is going to be on that red line is directly related to your decisions on sustainment, right? If you could, theoretically, if you think about it, if you have digital enablers that allow you to affect the slope of that green line, maybe bend it to the right just even a little bit, right? It slides that probability distribution function to the right, which means that you are able to leave components on a little bit longer, able to maybe have less sustainment costs, and you project that out from the asset level to fleet, and that could be a pretty significant, even a 2% adjustment in that could be significant, right? So to be able to have digital enablers that allow that kind of insight can be really important. Okay, if we go to the next slide, please. So the fatigue life predictions for something like drive systems, like our solution does, is they can be very computationally intensive, right? We do ours in a high performance computing environment, so they obviously take a lot of horsepower. But I think one approach that can make this solution more useful in the sustainment enterprise is to simplify those models and create reduced order models that are less computationally intensive and are suitable for deployment in the enterprise, right? Potentially in an onboard environment, but it could just be, in some of the offboard enterprise analytics. But the idea there that you create these baseline models that are used using the HPC resources that leverage all the technical data and all the design information, right? So you have that baseline model that theoretically all the aircraft in your fleet are built against, right? And then you can apply it to an asset-specific life model by updating it with usage data. Go to the next slide, please. So this is kind of our ultimate end state vision on how that works. Is you've got a series of baseline models or a set of baseline models that would be related to or tied to the design of the system. And every aircraft at its entry into service, they all kind of start at the same point. And then over time, as they develop their own unique operational history, usage profiles, maintenance activities, et cetera, over time, those models start to diverge. And what you've got is you'll have a population of users that may fall into like a heavy duty user category where the damage accumulation in those drive system components is accelerated because of the way they fly or the operations that they're doing. And then you may have less strenuous flight activities that fall into the light duty users, that those drive system components are accumulating less damage. So at the end of the day, not all flight hours are created equal. And so to be able to have digital enablers that allow you to kind of parse that out, to be able to allow you to tie usage to damage accumulation in a way that's consistent with the design methodology that was used, to design these drive systems, can be really powerful. And so this right here is not a trivial activity for sure. I'm not telling you that my company is able to do this right now. What I will tell you though is that we have developed the core technology in collaboration with DoD that forms the baseline for this. And now we're working with partners to be able to kind of advance towards this ultimate vision. I think that by the time future vertical lift hits the streets, this kind of thing will definitely be achievable. Okay. I know we got limited time, so I'll kind of get off the stage real quick.
Okay, Brandon?
Yes, sir. Can you guys hear and see me okay?
I can hear you. I can't see you yet.
You guys have video okay yet?
Yeah, we got you.
Okay, fantastic. So like Pete, I also missed the memo that we needed to prepare a brief and a talking segment. I thought it was going to be more Q&A. So we'll just
not required, Brandon.
well, I'll pontificate on a few topics here I think that might be of interest. So one chord that kind of struck in today's discussion was the discussion on source of truth. I come in from a background in, spent about half my career in intelligence, and so when I look at a source of truth, I think every data point that we're able to pull in from from an OEM perspective, from our internal systems, from fleet operators, from other stakeholder organizations, consider them all as observations on the truth. Consider them all as having some level of accuracy, some level of truthiness, and I think that'll bring us a long way. Just as we can't treat any data point as 100% accurate in and of itself, although tying into source systems, systems of sources of truth, systems of record, et cetera, helps improve that level of truth and that level of confidence so that we can use it to take action. There's interest as we start looking at some of the more complicated uses of data, say part lifing, part relifing, have much higher standards for data integrity, data completeness, data accuracy. Improvement is, as Pete was showing on the video about 525, improvements in the ability of an aircraft to self-report configuration, I think is key to that, as well as enabling other scanning technologies like RFID helps us improve the confidence of that configuration. But I also heard it said earlier, OEM data is key for that relifing. I think it really comes down to a combination of that OEM data on the product design. It comes down to the operator data on the usage and configuration and environmental exposure, and all of that is equally important to achieving this end state that we all want to be at. And the end state is, we've got many different things, many different activities within sustainment we perform, everything from reliability and maintainability analysis, supply chain demand forecasting, determining level of repair, pre-positioning parts, optimizing cost, achieving readiness objectives, and maintenance-free operating period that was also mentioned a bit earlier. So we're going to have different levels of confidence and different truths, perhaps, that we're going to need to achieve for each of these different purposes. So I think as we talk digital enterprise, DE is essentially a means of providing access to data that folks trust for a particular purpose. And as we see, there are different DEs, quote unquote, essentially stood up for different organizations. So when Bell talks with its large fleet operators in the commercial business, they're working on gathering their view on their fleet with their perspective. And Bell then figures out what is the intersection between the information they have, what are they willing to share, and how can we use that to benefit their business, to benefit our products, and to benefit our internal business operations. So I think it's also key to look at each organization essentially having its own set of truths, and hopefully we identify the intersection between organizations where we are interested in sharing those truths and willing to share information. So, considerations for access controls, attribute-based access control, role-based access control is certainly key. Watching out for intellectual property rights considerations and operational considerations, for military customers. Got to watch out for security classification and other items like that. So source of truth and authoritative source of truth, single source of truth. I just want to make a point, at least from my perspective, is look at it at levels of confidence, and we need to work to improve that level of confidence. And so the second main topic I want to talk about was the availability of data. And I think this ties back into the source of truth and the trustworthiness. So as Bell has continued to grow and mature over time, we're getting much better access to information throughout the enterprise, visibility of what data is out there. And if you rewind 10 years ago, someone coming in would be looking for sets of information, and they might not even know that they exist. They might not know what systems they're in. They might not know the point of contact to reach out to. And the maturity, the improvements that we're seeing over time allow us to better connect the dots. They essentially allow us to connect the digital thread through the various systems and the life cycle of the aircraft. And this includes reaching out to our fleet operators, getting into their maintenance data and saying part movement and installation and removals, and feeding that back into our reliability boards to understand performance, failures, opportunities for improvement and product design, maintenance steering guidance 3 processes. But having the availability of data, knowing what is potentially out there, I think is another key attribute in the digital enterprise. Knowing, a data dictionary is a term you hear in the IT space, but making it more systematic, making it not tribal, where you have to, I know a guy or gal and I can give them a call and they'll tell me where it is and how to get it. Facilitating access is going to be pretty key. But also with access, with many analytical efforts, as anyone that's been in the data science space, you start touching a whole bunch of different data sets and bringing them together. You touch in a few different rice bowls, different organizations with varying and sometimes overlapping, sometimes oppositional interests, and finding out the intersection between that and how to address it. In some cases takes culture change, in some cases takes systematic development and process and governance changes. Looking at it from a full .mil-PF perspective, and make sure that keeping folks involved through the process will certainly help. We've got metrics. Just one good example, we've got metrics in one organization, typically held pretty tight by one of the functional organizations. There's a lot of opportunity for use of those metrics in another organization, but historically, it's been on a very limited transactional basis. So when we start talking digital enterprise, systematic access to data, systematic access to cross-functional information, you start tapping on a lot of those concerns and those sensitivities pretty quickly. And so then we're talking about connectivity between networks, if we just talk Bell Commercial, between our internal organization and between our fleet operator organizations. We talk military, between Bell and our military customers. In some cases there are classification concerns, in other cases it's just how do we streamline connectivity of information from one system to another. And some traditional practices require a named user to access information, and we got to make sure that we've got the ability to exchange that information system to system, so that information can flow continuously, because as soon as someone goes on vacation, the data stops flowing. And when we've got, when there are activities that depend on that information, then that puts those potentially at risk. So third point is data exchange is absolutely key. Data exchange, interfacing, interlinking is all going to be key in the digital enterprise space. So we found that we get best access to data when data is explicitly identified in a contract. And approaching a contract, one of the challenges is to know what data one would need, which systems that data is in, and which systems to request. And sometimes there's a timing concern of when, trying to figure out what the data requirements are that you place into a contract. So having something akin to a DE poses a great opportunity for better collaboration between OEMs, between industry and government, between OEMs and commercial fleet operators, because it helps you have that visibility and information that's available. But once you have information, trying to take action on it, quality is a big concern. Everyone's seeing bad configuration data, bad serial numbers, typos, missing maintenance records. Whether it's due to lack of data or classification of data that can't be shared, there's many issues, many underlying issues. But when we talk about addressing it, part of it's do you push these capabilities onto the aircraft? Do you push it alongside the aircraft? Do you push software out to the edge? We heard in the Microsoft discussion, about trying to get more capabilities out there. I think that is potentially part of the solution. But we also need reach back from the enterprise level. So when we talk about fleet operators, they might have multiple facilities and they need their headquarters to assess the fleet and send out guidance. If you talk military, you might have headquarters, PO Aviation needing to reach out to different squadrons, different companies, different operating organizations that might need that guidance. But there's also opportunity for OEMs and other third parties across the ecosystem to help provide their analytics, their insights to help benefit cost, readiness, reliability, maintainability, supply chain responsiveness, et cetera. So streamlining all that data exchange is pretty valuable, supporting the system-to-system integration and connectivity and flows of the data must flow. I'm a Dune fan, so the spice must flow, the data must flow. On that, that's my 3 points. Any questions?
Most everybody here answered. The whole data piece of this is, I consider it an enabler. How is Bell handling dynamic lighting as a approach in calculating remaining useful life versus a TBO approach? Grant?
So this isn't exactly my expertise right now, but what I can say is we have had examples where through teardown of components, through gathering of HUMS data and assessment of vibration levels, through analysis from some of our engineering organizations, they've been able to achieve some of that relifing, but it's more so on a limited basis. We do have capabilities where we've estimated remaining useful life, and the lack of integrity on aircraft configuration ended up being the obstacle that we were not able to overcome. So I think the discussion about AI and ML being, it being able to help, but it's not necessarily the problem. It's not the alligator nearest to the boat. I think ensuring that we've got accurate configuration is, in my mind, one of the top priorities out there. Maintaining visibility of parts throughout their lives, the digital thread is absolutely key.
Okay. Jason, you want to try that one?
Sure. Make sure it's green.
I think it's green. So yeah, I agree with everything that Brandon said. Also, I guess maybe from our narrow point of view, we see technology like the modeling capabilities that are out there as being definitely capable of providing those insights. I think the biggest challenge in implementing it will be the building the trust in the models, and that's going to take time. So I think for aircraft that are in development, being able to apply those technologies in parallel to some of the qualification testing and stuff to be able to maybe build that confidence during qualification test, I think goes a long way. But I think the existing technologies are certainly capable of supporting those kinds of decisions, but it's a big decision to move away from a TBO type, lifing model to something more dynamic, and it's going to require an enormous amount of trust in whatever you're going to. And so for us, I think the models would have to earn that trust to be able to be put in a position to support that.
That's what's probably not as big a risk as Nick suggested, taking our 1.5 safety factor and putting it down to 1.0.
Right. Right.
Paul, you want to try it?
Yeah, I want to kind of hit on a couple of notes here. First off, we've been here talking all days about new procurement and MOSA, but if we don't think in our hearts and what we do that sustainment is the number one task, we're going to fail everything we do. I mean, it's just that we cannot survive as an enterprise or a country anymore with the ACE by waste numbers that we have. Just can't throw money at it and enough assets. It will not work. So I hope that's ingrained in us from our soul. I know we have a lot of passion in that.
Well, and let me stop you there. And if you don't design it into the aircraft, you will not achieve that outcome.
Right.
Okay.
Then the next part is when we design our systems, we have to design them for sustainment. So we talked a lot about a single source of truth. I'm just going to go back to the F-18 program. There's 400 airplanes that have got 40 years of service life on them, and mods and change orders and whatever, that we make now unique twins from that single source based upon its life. So we're playing catch up on it again. What we also have to think is that every time we put out a new asset, it's going to have its own data twin, whatever you want to call it, okay, with it. And we have to be able to adapt and be able to use that. And the last one that I'm going to really get onto a lot is, we have to be more predictive, like Jason was saying. We just can't change parts because it's Tuesday, whatever it is. Even this microphone that I have here will blink at me with a red light, needs a battery. Change it before the part of it has it built into it. So guys, we have to start thinking in everything we do that's going to be more condition-based, more predictive, rather than putting burden on scheduling on our depots and our soldiers.
Yeah, totally agree. I just, to the point of going from condition from TBO condition essentially. I just think the variables are so high in the model that it makes it some way impossible unless you have a good handle. Even something as simple as how the pilot flies. I mean, I'm both dead side every time I say, oh, you don't. What is that impacting and how do we quantify that? Makes that extremely difficult.
Okay, other questions? Nobody online? Is anybody online?
I don't see any questions online.
No question?
It's either it's late or it's
Okay. Last chance, folks. All right. Hey, thanks. I want to thank the panel. Appreciate you coming out, giving us some of your time.
Thanks for the opportunity. Take care.